A nice thing about AP chemistry is they're always considering what's actually in the flask or what's actually in that lake when they're considering things on a molecular basis. If you have ionic compounds and you throw them into water, what happens? Well, some of them don't dissolve at all, some of them dissolve a lot, some of them dissolve a little bit. So you can have strong electrolytes, weak electrolytes, and non-electrolytes. Let's consider what happens to each of these when we huck it into water. That means they want us to write the aqueous dissociation reaction with water. Well, sodium chloride is a nice strong electrolyte. It's going to dissolve totally, being group 1. And therefore it'll form the sodium cation and the chloride anion. Aqueous means everything's in solution. Don't peek at that. HCl in the presence of water, that's a strong acid. That will also form H plus and Cl minus. But if you're going to write it out technically, you don't just write H plus, because H plus got pulled off by a water molecule. And therefore, technically, it's going to form H3O plus, which is known as the hydronium ion, and Cl minus. If you simply wrote these dissociating into H plus and Cl minus, people know you know what you're talking about, but since it's in water, this is a somewhat better answer. Hydrofluoric acid. Do you recall that that's just a weak acid? It's got a very low dissociation constant. So that you better use your double arrows for. That's going to be an equilibrium situation, where it's going to form some H plus and some F minus. Written here, of course, as the hydronium ion. Sodium hydroxide, strong base, complete dissociation, no need for the double arrows. Perchloric acid, strong acid, complete dissociation. Not sulfuric acid, but the hydrogen sulfate anion. But there's still an H there. Is this thing an acid or a base? Well, it's a weak acid. It can now dissociate, but it doesn't dissociate much. You need your double arrows. Notice that when this loses H plus, it becomes 1 more minus. It's now at 2 minus. And F minus, what the heck would that do? Well, that is weakly basic, and it will react with water to form just a little bit of hydrofluoric acid. Hydrofluoric acid, in this case, would be the conjugate acid of that weak base. Okay, so that is a little bit about the interaction of electrolytes with water. Let's take a look at it on a larger scale. Here's a list of all sorts of acids and their conjugate bases. So perchloric acid and the perchlorate anion, working your way over. Notice these things are getting stronger and stronger in their acidic strength. Perchloric is very strong. And the conjugate base, the base strength increases as you work your way down. You do not have to memorize this list, but it's nice to see how they relate. And this is a little bit about acids and their conjugate base strength.